Hi and welcome to our third video on P1 physics. This one is on the topic of waves. So first of all, there are two different types of wave, transverse and longitudinal. Transverse waves are where the vibrations are perpendicular to the energy transfer. That means as the particles move up and down, the energy moves across at a right angle. We can draw a transverse wave just like this. The distance from one peak to the next peak, or one trough to the next trough, is called the wavelength. The distance from the baseline to the peak, or the baseline to the trough, is called the amplitude. All electromagnetic waves are transverse. The second type of wave is longitudinal. Longitudinal waves are where the vibrations are parallel to the energy transfer. This means that the particles vibrate backwards and forwards as the energy transfers through. Where it's squashed together is called a compression, and where it's stretched apart, a rarefaction. One wavelength is from a compression to a further compression. Sound is an example of a longitudinal wave. There's an equation we can use to work out the wave speed. Wave speed, measured in meters per second, is the frequency in hertz times the wavelength in meters. Make sure you use your standard units and remember them for the exam because you don't get given them. Frequency is the number of waves passing a point per second. There are three rules you must know: reflection, refraction and diffraction. First of all, refraction. Reflection is where the angle of incidence is equal to the angle of reflection. We say the image is virtual and laterally inverted. That means when you're looking in a mirror, your right appears on your left and vice versa. The second law you need to know about is refraction. Refraction is where a wave changes direction as it goes from one media to another. So for instance, as it enters a glass block, it bends towards the normal because it's going from less dense to more dense, and as it comes out again, bends away from the normal as it goes from more dense to less dense. Notice that the incoming ray is at the same angle as the outgoing ray. Diffraction is just the spreading out of waves. The smaller the gap, the more it spreads out. Think about it, it makes sense. If you all ran at a small door gap together, eventually you would push through and just spread right out. If the gap was big enough, you would go right through it without spreading out anyway. You've got to know the 7 regions of the electromagnetic spectrum: gamma, X-ray, ultraviolet, visible, infrared, microwave, radio. And you need to know some basic uses of each. Gamma is a really short wavelength, high frequency, high energy. We use this to treat cancer. X-rays, still very high energy, not as short a wavelength as gamma, but we use it to look at bones, broken bones. Ultraviolet, to detect counterfeit. These are free ionising radiations. Visible to see, infrared for cooking, that's what you see in your grill or your toaster. Microwave, to cook food or in mobile phones, and radio waves for communication. These are the longest wavelength, lowest frequency, and they're low energy. The Doppler effect is the effect of where sound waves change in wavelength. You've all seen this. You all hear the difference as an ambulance comes towards you and moves away. As it comes towards you, we're pushing the waves together, so they become a shorter wavelength, so a higher pitch and a higher frequency. As it moves away from you, the waves are stretched out. As they're stretched out, they become a lower frequency with a longer wavelength, so it's a deeper sound. This is very similar to redshift. Redshift is the stretching of light waves. When a galaxy is moving away from the Earth, it stretches the light waves being given out, and pushes them to the red end of the visible spectrum where the light rays are longer. This makes it appear red. The further away something is, the faster it moves due to the force of gravity being weaker, so it will appear redder to the eye. Redshift is evidence for the Big Bang Theory, and I don't mean the TV show. I mean the universe starting from a single point and it's been expanding and cooling ever since. There is one other piece of evidence for the Big Bang Theory, CMBR, Cosmic Microwave Background Radiation. This is the remnants of a huge explosion that supports the Big Bang Theory. This is all you need to know for the waves topic. We'll leave it up for a few seconds in case you want to take notes from it.